Hello students, welcome to the session. Today's topic for the session is perpendicular from the center from your chapter circle. So we will discuss this topic. So this is a theorem very important. The perpendicular from the center of a circle to a chord bisects the chord. So what is the theorem? This is very important. It has a very vast application. The perpendicular from the center, the perpendicular from the center of a circle to a chord bisects the chord. Okay, so that means if we have a circle and the center with center O, okay, so a chord PQ, we have a chord PQ, of a circle with center O and radius are perpendicular OL to the chord PQ. Let us have a perpendicular OL perpendicular to PQ. So we have to prove that LP is equals to LQ. Okay, so bisects the chord. That means if a line drawn from the center to the chord perpendicular, okay, that line should be perpendicular. More precisely, it should be perpendicular. Okay, then this PQ line will bisect. Okay, that means this will be divided into two equal parts. So let's start the proof. So what is the given in these cases? The chord PQ is your chord of a circle, center O and radius R, and perpendicular OL to the chord PQ. Okay, perpendicular OL to the chord PQ. So we have to show what LP is equals to LQ. So what we have to show? We have to prove LP is equals to LQ. Okay, now let us do a construction OP and OQ. Okay, this is the construction. What is the construction? Done. Join OP and OQ. So what is your OP? OP and OQ is your basically radius. Okay, so they will be equal. So let's start the proof. So OP and OQ, they are radius. So let's start the proof. So we will take the two triangles PLO and QOL. Okay, so these two triangles we will take. These two triangles, this one and then another this. So in both these two triangles, these two sides are equal because they are the radius. OL and OL, they are common. And one thing is that it is 90-degree given since it is a perpendicular. So all these three will be helpful in proving that it is your congruent triangle. So after proving the congruency, the rest of the part, that is PL and LQ, they will be equal by your CPCT. So that means if your PL and LQ are equal, that means that OL is bisecting the line PQ. If you are able to prove that PL is equal to LQ, that means they are now equal, and we will be proving it by concurrency. Okay, so if you get your answer PL is equal to PQ, then we are done, because we want to prove that this OL, this perpendicular, is dividing the line PQ into equal parts, that is your PL and LQ. Okay, so that means if I take this first triangle and the second triangle, so my OP is equal to OQ, it was equal because of the radius, same radius, and OL equals to OL because it is common. Okay, next is your 90-degree. Okay, that was your perpendicular. OLP is equals to angle OLQ, that is your 90-degree. This is your perpendicular. Okay, So that means these two triangles, triangle PLO is concurrent to triangle QOL by RHS concurrency. Okay, it is your RHS concurrency. How? Let's see again. RHS. That means right angle, hypotenuse, and side. You have used your right angle. This opposite is your hypotenuse, and this is your side. So we will give preference to RHS. So your RHS, by the help of RHS, it is proved that these two triangles are concurrent. So rest of the part, that is what was left, PL and LQ, that was equal because of CPCT. So that proves that any line in a joining from the center to the chord perpendicular, precisely perpendicular, it will bisect the chord. Okay, so this is your theorem. So let's do one numerical based on this theorem. The radius of a circle is 13 centimeter and the length of one of its chords is 10 centimeter. Find the distance of the chord from the center. Find the distance of the chord from the center. See, you have a circle with radius r as your 13 centimeter, and the length of one of its chord is your 10 centimeter. Okay, so this is also my radius 13 centimeter, and I know the perpendicular drawn from the center to the chord bisects the chord, and I have to find the distance of the chord from the center, that is the distance OP I have to find if it is A. So I have to find my OP, and this chord is now bisected in two equal parts, so this will be 5. This is your 13 by Pythagoras theorem. We can easily find it OP as 12. So by Pythagoras theorem, OA square will be equal to what? OP square plus AP square. So it is given that OA square is OA is 13, so it will be 169. OP we have to find it, and AP we know it is 25. So 169 minus 25 will be 144. Square root of 144 will be 12. So OP is your 12. So this is how this theorem has a very vast application, and we should have a more clear concept regarding that. Okay, so that we can easily solve the questions related to this. So I hope you understood this topic, and if you have any doubt, you can ask me through my Urban Pro profile. Till then, revise, and let's meet in the next session. Thank you.